नहीं गया बाहर, बुला लो उसको। कम लग रहे हैं कुछ लोग। कहीं छोड़ आए क्या अपने दोस्तों को तुम लोग हैं? चलो गाइस, लुक अलाइव, we'll start our last section of the day. And so for this session we plan to do something a little unique. So raise your hand अगर तुम में से किसी ने, or have you ever tried replicating a paper in some form, like whatever, if there was something in the paper you tried doing it. Let's see if we can do it or not. So today's session we will try and see if we can replicate a paper. So for this paper, for this session, what we are planning to do is we have this paper from CVPR 2020 that came out from Oxford, and the name of the paper is Seeing Red. Now I'll take you. Hmm?
So
That's it.
some of you just showed you rose your hand when he asked the question that you implemented some paper. Can you briefly describe what did you do very briefly? Maybe you can start. I saw you raising your hand. Okay.
uh, the if you have values of like if someone has hypo or hypothyroid disease, then there are some values, right, like TSH and so on. So tabular data anomaly detection would be if the person does have that disease, then it will be detected. So the we had I redid the technique on implemented it on audio. That was on tabular data and moved it to audio.
Okay. So do you know where was this paper published or something? Do you have that information?
Yeah, it was. I mean, it was. I think it was from. I don't remember right
So,
now, but I.
I'm just asking for some different perspective. Anyone else? Yeah.
Uh, like give a brief, like
Very brief, just one. I
very,
just want to get to know the idea
that,
of.
I have actually tried to implement three papers. So one of them, so the authors of that paper proposed that just by a single image. So it was an unconditional gain, and it was very recent, and it also won the best paper award of. It was, I think, ICML or ICP or something conference. So
Okay. Okay. So, just quick question. I got some ideas. Quick question. So, if I'm not wrong, has anyone used a paper and so you do some kind of software coding, you open your laptop, do some software coding and then implement the paper. Anything with hardware ever? Do you have some kind of hardware with you?
like who uses hardware to like do some stuff?
Software, everybody does. Okay, you do. I'll come to you. Anyone else hardware? What hardware do you have? I didn't hear that. Okay.
Yeah, basically, I plan to build a wall climbing robots.
Okay. Have you done that or you're
No,
planning?
no, I am planning and
Okay.
I am basically progress on to how to run on the wall purpose, but we have to automate that. If we give any coordinate that it's move on only that only it's.
Okay. So, okay. Nice. Oh, what are you, do you have a hardware? Not now, but you have worked with hardware. Raspberry Pi. Okay. And none of you have any other hardware? Servo motor you have.
So if I say that you have a very powerful, strong piece of hardware with you at the moment, would you agree? Like very powerful. What is that? The smartphone. Yes. How many sensors does a smartphone have? 8 to 10. Like, can you name them? Hmm. So your phone is a very powerful set of sensors, right? So there's like people that uses smartphone to do something, right? Sometimes they do it ubiquitously, sometimes they do it like, for example, can you use a smartphone for a first aid? Right, all those setups. Let's say if you do not have a very specialized machinery, you don't have a very specialized hardware, can you use a smartphone as a proxy or an auxiliary tool to do it? So this paper, like seeing red, PPG biometrics using smartphone camera, it came out in 2020, and I feel like this is very nifty. This is a very unique, nifty, small idea, and it's just sometimes I feel like small ideas, but they could be very big. So what this does is it uses a smartphone camera to estimate heart rate. So how many of you think it is possible? Can you estimate heart rate using your smartphone camera? Have you tried?
Why do you think so? Oh, you tried?
Others, not
Okay,
not
yeah.
others.
You were smart in this league.
Yes. So
Others, oh, why do you think so that it is possible? You must be thinking something, right? Yeah, and in any order. Those who, yeah. So many of you think it's possible. Just asking.
so those people who thought it is not possible to estimate heart rate, why do you think it was not possible? Hmm. I could not get it, but
Didn't understand. Can you?
haha. But what was your prior motion before we talked about? Mhm.
Yeah, you can tell what.
Yeah,
you
it's
think
possible by monitoring the changes of pixels value.
Pixels where
Yeah, pixel intensity value
of what?
of image.
Of what image?
Click from normal mobile phone.
Okay, okay.
Yeah.
Yeah, that's good. So this will keep it very interactive. Okay, it's going to be chill. So this yeah, Rishabh. Why 10 second? Why 10? Yeah. But why 10 second? Why 10
Yeah,
second?
just a
Okay.
normal frame. 10 second, you can take 1 minute as well. Okay. Then analysis the frame 2D to 1D signal and then make
Okay.
then
Interesting.
learn that thing and
Okay.
predict.
Shall we all do this?
This would be interesting, right?
Let's take out your phone. Just take
But
out.
before that, so this is how PPGs work, right? In the meantime, you're taking out your phone. What PPG does is it shines a light from one end and it tries to record on the other end. And as your blood flows through that light, the pixel intensity of the light changes. And that intensity change determines your heart rate. So something like this. Now what we're trying to do is, I want you all to take out your phone. Like, I have this here. What you need to do is, open your camera, go to video, and put your finger over your camera and record a 10-second window. We don't need flashes. I mean, flashes would also be good. You can record a 10-second window. Like, can a few of you observe that your video sort of blinks? It pulsates, right? So that's the principle we are going to use. Record that 10-second or 20-second, how many seconds you want. We'll use that. We'll use that.
You can use your flash, but in that case, cover the entire finger with the flash.
Yes.
Right? Make sure. I mean, it depends how is it positioned, but try to cover so that the light hits the finger, reflects, and goes back to the camera.
So either you use
Or you don't use it.
or you don't use. I prefer not using.
I prefer using. So let's see.
So there is 50-50. I see a few people are still trying, so we'll wait for 5 minutes. So all of you are done. I urge everyone to try this. This is a demo that you guys will build on your own. So this is something you would be seeing on your screen, right? Your video would be pulsating, और हिंदी में बोले तो ऐसे दुब 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 हो रहा होगा उसमें, है ना? So now let's. So has everyone collected this 10-second, 20-second feed, right? Now we'll try to visualize your heartbeat. Like how did they look like? I want you to go to this URL and download the collab notebook. It's an IPYNB file. I need you to download it. I also need you to send the video that you have taken to your laptop. So two instructions: download this IPYNB file and then also load the video file that you just recorded and place both of them in a single folder so that we can use it. Don't have access? Okay, I'll give you. Can you guys try now? Do a refresh and try again.
Sir, Ayush, sir, please give access. Like, can you give link to that site again? Like some of them
Yes, yes.
wanted.
Can TS just navigate around and see if things are in order? So I repeat the instruction. Download this collab file. This is an IPYNB. Also load the recording that you have just recorded, 10 second, 15 second, 20 second, whatever you have recorded, and place both of those files in a single folder.
So there is a reason why we're doing this activity with all of you. We want all of you to record because every phone is different, right? So we are expecting a lot of changes depending on what the make of the phone is. So some people are saying me that they are not observing any change in the video. Maybe we are not able to visually see the change, but maybe the algorithm will see the change, right? We don't know. So let's just record and proceed with whatever you've recorded.
Also try with, if you don't see any change, try with a different angle. Yeah, sometimes it is sensitive to light. Like move your finger a little around and see. Ideally, record a few 10-second fragments, 3 or 4 or more. Is everybody done? Has everyone loaded both the IPYNB and the video recording to the same folder? Who is left? Raise your hand. Okay, okay. There are a few. So why I like this paper? Because the idea is very simple, right? Anyone can implement it. People just don't think about it. There are a lot of simple ideas out there that we can work on, but we only realize that, oh, it's a simple idea when once it gets published. And then it's like, yeah, ye kya tha? I could have done this. Even I could have tried this. People having issues? Anyone? Everyone done? Okay. TAs are telling me that we should wait for a few more minutes. Let's wait for a few more minutes. It seems like even TAs are trying. Okay. So how many of you guys have used OpenCV in some way, form? Sorry? So I said download the CV, download the file in your local. Sorry? Works on the collab. So that's why I told you to download the file. So download this IPYNB file on your local machine and then use it. This does not require a lot of intensive GPU, CPU support. It's a simple script. Download this file. I shared Collab because it's easy to share using Collab. If you want to use using Collab, you should disable or comment that line and it should still work. Or that. Also, how many of you here have done some basic signal processing like low pass filter, high pass filter? So, do you have knowledge of what a filter is? Who has not done signal processing? Like, can you try what a filter would be doing? Yes. Yes. So a low pass filter, as the name suggests, would allow the frequency later, like allow the frequency of lower frequencies to pass. A high pass would allow higher frequencies to pass. A band pass would allow in a band. So you have to specify these. In a low pass filter, you would give a cut, low cut, high cut. So based on the cut, all the frequencies below that frequency would be allowed. and all the above frequencies will be stopped. We'll use these. Shall we move forward? Okay. So we'll begin. So the first block is very important. It will tell you your FPS, frames per second that you're recording. My camera recorded 30 FPS. I assume every camera, like every smartphone camera would record at 30 FPS, but we don't know what the make of your phone. You may have very different specialized camera that would record at higher sampling rate. Standard. No, no, no. No, give me that. Just function. I did this.
Who has higher FPS than 30? Anyone? How much is it? How much? Oh, wow.
60.
Okay. Interesting. Okay. Anyone? 60. 60.
Ah, yeah, same. 60 only.
Yeah. Interesting.
Anyone lower than 30? 24. Ah, 29 is also okay. It is 30. Basically, sometimes it happens, like you may lose a frame or there.
So, those who got 60, 60, 59, can you just, the make of your phone?
What's your phone?
What's your phone? Oh, nothing. Nothing.
Nothing phone. Okay.
Okay. Wait, there's no consensus. What's your phone? Okay.
So what we're trying to do is, so you saw that your screen was pulsating, right? When you were trying to record your finger. So what we're going to do is, just take the mean entire frame. Take the mean of the entire frame and save it in a signal variable. And we keep appending it to make a new signal. So this is what this code does. It opens your video, it takes the mean and then stores it into a list. Now my question here is, when you record a video, you generally have three channels, R, G and B, correct? So which channel do you think should give us the best signal, R, G or B? Or it doesn't matter, we can take any of these. What's the consensus? Does the channel matter or not? Yes or no? For those who think yes can raise their hand. Will the channel? Will I get a different signal, or does the signal should remain the same? If I use green channel, I'll get a different signal. If I use a red channel, do I get a different signal? Do I get a blue channel? I'll get a different signal. Is that so? Or it doesn't matter what channel you use, it's all light and it should remain the same. People who think it will remain the same. So no one thinks that it will remain the same. There's one person who thinks it should remain the same. And the others think that it should vary. So can anyone try and guess why it should vary?
Different identity. That's why the PPG on your watch is different. It's green and red, I think, or blue. So I think they're like oxygen molecules. That's how you check the variability and stuff.
So there's a technical question. When you read a file using OpenCV, what format does it read it into? RGB or VGR? VGR, right? So what I'll do is, I'll take the blue channel and we'll try to plot the signal. So this is the video that you can see the blinking, right? That's your heart rate. Now I'll try to visualize the signal that I've gotten. This is what I get. This is blue channel. Do you see the heart rate here? This looks like something, right? At least it is something. Now let's try with the green channel. What do you think will happen? Will it change? Will it remain same? Will it be better or worse? Who think it will be worse? No one thinks it will. So this is what we get. It gets worse. So green is, maybe it's not a good channel. Then I'll try with red. Any guesses what will happen? Worse, better? Okay, let's try visualizing. Do these look like good signals? Can you see, like, okay, this seems like it is not a random signal. This should definitely correspond to something. Correct. Here we were talking about filtering, right? So what would happen if I do a high pass filter here? What would happen when I do a high pass filter? I think so. Sorry? Yes, low frequencies will be removed. So how many of you here understand that the DC gain of a signal is at zero frequency? It's too technical to understand. So basically, a straight line at some amplitude, what is the frequency it has? You have a sine curve, you can say, okay, but what if I stretch it out? What frequency should it have? Yes, it just becomes one straight line. Yeah, but what happens is that is a DC gain, DC offset. It sits at zero frequency. So if you do a high pass filter, you would take the signal down to 0 milli. And if you were to do a low pass filter, you would remove all the higher frequency component, but you would still have a offset. So it would still be high in the air. So what we'll do here is we'll use a band pass filter. So we'll remove the lower frequency component and we'll remove the higher frequency component. And how do I know what frequency components to remove? So what is a typical heart rate? Like when I do say, what's a typical human heart rate like? What's the number where it should lie between? 60 to 90, sometimes it goes over 100. So if I say, let's say if I take something between 30, so 30 breaths per minute, 30 beats per minute, right? 30 to 150 beats per minute. 30 corresponds to how much, what is the frequency? 0.5. 0.5 per second. So you should get 0.5 frequency, like 0.5 signal per second. And if I go to 150, it should be like 2.5 signals per second. Basically, by 60. 30 by 60 is 0.5. 150 by 60 is 2.5. Yes. Let's say 30 to 150.
So we concluded that the heart rate may be 30 to 150 beats per minute. And what we are discussing is these numbers, you need to convert it to frequency.
Which is per second.
So beats per minute. Now I need signals in per second.
Per second, yes.
So it is 0.52.
2.5.
Okay, yeah, 2.5. So this is hertz.
Yes. The above one is in per minutes. We just divided it by 60.
So I hope it's clear how that conversion took place, right? It's something is in minute, we just convert it to per second.
So now I'll pass my signal through this filter and this is what I get. So the first observation I want you to make is it is centered around 0. This one was somewhere up in the air because you're taking the mean of the entire frame. Now the mean of the entire frame could move anywhere. You have no control over it. Here we have brought it down to 0. We have essentially removed that DC gain. Now this is my signal. If I have this signal, what could be a few methods to estimate the heart rate? Anyone who ever estimate whoever try to estimate like what should be the frequency of how many oscillations per second I'm having? What's the most naive way? If I tell you, you have to count number of beats in a minute, what should be the most naive way to do it? Count the peaks, right? That's the most naive way. So we'll try that. We'll estimate using peaks. So SciPy has a very good algorithm find peak. How do you find the peak? Like what defines the peak? Like anyone wants to try defining a peak? Yes. Yes. So that value should be greater than values that are on the right, on the left, and which are greater than on the right. Right. So it should be sort of like a mountain. There are different variables that you can put here. It should be greater than points, like 5 points ahead of it, 5 points behind it. It should be like have this characteristic. It should have like at least a difference of 0.5, 0.1. All those things you could set. Those would be your hyperparameter for this algorithm. Here I've not set. It said height should be 0.1 and distance should be 0.5. It checks with 5 neighbors. So basically, I get this sort of a signal, and the red is the peaks. So I feel like the peaks are being identified correctly. Now, the number of peaks in a minute is your heart rate, correct? Here I have a 10-second window or whatever second window. How do I convert it to a breath per minute or convert it to a beat per minute? You can use a unitary method from 10 seconds to 60 seconds, and basically we try this out, and it says 68.75 beats per minute. What does yours say? Did you guys try? So these are in reasonable limits, right?
Okay, interesting. Just
Uh-huh.
I'm trying to collect some interesting insights here. So what was your number? 79.4. Yours? 60. Did you do it?
68.
68, 60. Okay. Okay, 82. Okay. 82. Who is 82? 85. Okay. This side, anyone? How much? Okay, 72. Anyone from boys? How much?
72.
Okay.
Who is this nervous person?
90 point. Who said 90?
Okay.
Okay, 90.24.
114. Oh my God. Why are you running somewhere?
Okay, some interesting question to handle here is that why I was asking. I was trying to make a differentiation between males and females, but it's very mixed, right? Should there be a difference?
There's this concept.
Maybe
of-
not, maybe yes. It depends on the human's physiology.
So basically, there is a concept of something called resting heart rate. Resting heart rate. When you're at rest, your heart rate. So resting heart rate.
So resting heart rate usually will be lower is better. That doesn't mean like 10, 5, you will die. So lower is better. So some interesting insights, and which you can actually, which smartwatches usually do. Quick question. Which gender will have higher variability in heart rate? If I consider, say, a month data, suppose you're doing this every day, this task, of course, I mean, in a more disciplined manner, and assuming a healthy human, so you're not sick, you are not doing any kind of spatial activity, just a healthy human body, who will have higher variability? This means fluctuations, to say. Any answers? Female. And it's not difficult to guess why. Do boys know why? Yes, the answer is obvious, because of the monthly cycle. So that's a very classic indicator of when the body changes happen. The variability is obviously high. Just an interesting insight to note, right?
Okay, so we did using peaks, right? What could be a more nuanced method of doing this? Like you dig, like I know you do not have a very good signal processing background, but like, have you studied something that does something similar? Like, if you given a signal, have you ever heard or read of a tool that could dissect your signal into frequency components? Is Fourier transform, right? Fourier transform is a very classic tool, or some could think of them as an equation because that's what we did during our signal processing and such classes. Like, okay, signal ये formula लगाओ, कुछ answer आएगा. But what it used to do was it was used to dissect or break your signal into frequency components. So we'll try using that.
So before we try using that, quick question. So we were using peak detection to find it, right? So why are we jumping to Fourier transform? Like, of course, it's an interesting concept to learn, but what could be the problem with peak detection? What do you think? So here it was working perfectly fine, right? The Ayush which you showed looks like perfect to me. Every peak is getting detected. I don't see any issues. Do you anticipate some kind of issues here? Yeah, but in this case, some are low, some are high anyway, so it's getting
No,
detected.
anything in for him, some peaks did not get
Okay, for you, some peaks don't. Oh, okay, good. But any more? The answer is in the code. Look at the code, and I want to try. I want you to basically try out, not try out, observe something in the code, and answer this question with respect to the code that generated the peaks. Okay. Okay, we'll come to that. That's a little advanced, but we'll come to that. But I'm looking for a more fundamental answer, which is in the code. Perfect. Yeah. Parameter. Is it a parameter or a hyperparameter? Yeah. Right. Exactly. So that will change on for each one of you, right? That can't be consistent. That will depend on the signal. So for every individual, we have to change it, and we have no idea. Like I have no idea what his parameters are. Okay. Is it a hyperparameter or a parameter? Okay. What's the difference between parameter and hyperparameter? Okay. Yeah, close. Let's not go into that, but yeah, close. A very basic question. So, okay. So the parameter, in this case, I'll use the word hyperparameter because we don't have a mathematical way of defining these parameters. We don't know. So this will fluctuate for every individual. Ayush used some numbers which worked for him. The same may not work for others. So we are investigating a better way of like non-parametric way, or let's say non-hyperparametric way of finding the heartbeat. Is this clear? Yeah.
So like I changed my numbers a little. Now my algorithm is detecting the peak. It sort of started failing. It could happen for you as well. But it could happen that the parameters or hyperparameters that are hard coded might have worked for you. But it may not work in all the scenarios, right? And there might be, you could end up having, like, someone might be living a normal life, and then you're saying that this person is having a heart attack. They may end up having a heart rate of, let's say, 50. If that is something we don't want to give it to a user. Identify the most dominant frequency in the signal. So like I said, the Fourier transform can deliberately break down your signals into different frequency components. Here in the x-axis, we see the frequencies that could be in the signal, and these identify, like the amplitude here identifies with what magnitude they're in there. So the most dominant frequency is the one that we wish to get. So here we get the most dominant frequency, there's a peak. The chance of this or this is there with the most intensity. if we get using that, we see that my is 82.09, whereas if my beat, like here in this case, the peaks were being dropped, the detection, the peak detection algorithm says 34.45, 34.55. If I put the numbers back, what were the numbers? I forgot. Okay. 81.16 when it works right. And Fourier says 82.09. So not much of a difference when they work right, but there are chances where your peak detection algorithm would definitely fail. Is this clear to everyone? So how many only took one sample as someone took multiple samples? Took multiple samples? Does your heartbeat out of each sample similar or does it vary a lot? Varies by how much? 10, 30. That's a lot of difference. Did you do something wrong or your signals look off? 30 is a big jump, right? Sort of a difference between sitting and walking. So how many of you think this is sort of cool, like sort of do and like ऐसे किसी को चमकाने के लिए कि देखो तेरे कैमरे से हार्ट बीट निकाल के दिखाऊंगा, हैं? Just to off.
So, is there anyone who have difficulty understanding the code? I think the code is pretty straightforward. The whole idea is that, just to revise, the whole idea is that you're recording something, taking average, doing some filtration. You may skip the filter if the signal quality is high, and then you're decoding you are extracting out the heart rate. Everybody is on same page, right?
So while collecting samples, so there is one stagnant green dot in my earphone. So I've tried that sample, and even that shows the heartbeat.
Okay.
It shows around 56, 53. So what could be the possible reason of that?
What's the question?
So this is a very interesting insight. So he took he did the task that we asked him to do, and he was a little, maybe he was in a doubt, so he took video of his earphones charger. There is a green dot, there's a LED there which indicates whether it's charging or not. And now he says that also is showing the same kind of number, more or less.
Okay.
And he's like, how do I know whether what you're teaching me is,
Correct.
correct? That's a very good question, actually. Yeah. Anything could be just, maybe that means the numbers that you are getting, maybe it's not your heart rate. What do we do now? Very good. It's a nice observation. So you did some processing, got some numbers. How do we know whether it's correct or wrong? Maybe it's just some random number coming up from somewhere. Why? Yeah, she's like, you're teaching us, probably it's correct. How do we know? But seriously, like we are doing we're estimating a number, heart rate, serious numbers, and yeah, right. I was joking, she was seriously answering. So we need to cross check. So how do we cross check? With what? Yeah, so the naive method is that you take your own pulse, if you can, by conventional method, and compare it with but both of them may not be possible simultaneously, because how will you just record at the same time, record your own pulse? I mean, I don't know how you can do that. Okay.
So what I would suggest you is, in the band pass filter, there's something called high cut. You get the number to the higher side. Maybe there is something different signals that comes up, right? So because we are concentrating in that small band, you get the most dominant frequency in that band. But your actual signal may not be of a signal of a heartbeat. You're getting some signals. There could be some signal in that band. There is always going to be some signal in that band. But that is not your heart rate. That's what I'm saying. Now the question is, how do I know that is heart rate? Right. That's when you have to evaluate. Whenever you do a machine learning task or anything, you evaluate like how close the number that I get and the number that I get from the ground truth is. If those correspond very highly, I would have to conclude that whatever I'm getting is heart rate. And that's a whole study that you have to do. But this is a study you could do at home, right? You have your mother, father, sister, you just collect the data for 30 days. Like, I think we had one student who was asking, I don't have data, how do I do it? You can figure out such small problems where you can collect your own data, right? खाने के पहले खाने के बाद तुम करके देख रहे हो. Let's see if it changes based on blood pressure or blood sugar. Can you estimate blood sugar out of this?
So has everybody calculated their heart rate at least once? Feed the video, it's working, right? At least some of them, they have some problem with their OpenCV installation. Except them, everybody has, right? Any interesting insight that you are not able to record it, or it's very weird kind of curve? Anything?
One second. Can you get him the mic?
So my heart rate beats per minute. It's first time it was around 32 to 33, and second time for the another video with flashlight, it's 37. I guess 37 beats per minute.
Okay. So what is happening is this, what we're trying to do is a little sensitive to light. So if you press too hard, it will not work. You have to press it gently, and you could try it in different locations. So it is little sensitive to the light that falls upon, because we are inherently using light, right? So when you use a PPG or that clip machine, it's surrounded, right? It sets its own light and it reflects it back. Here there is a lot of different variation. Like even I tried it once. I pressed too hard, it did not work for me. So try tapping it lightly. Or maybe you're, because you have multiple cameras on your phone, right? Maybe you're putting somewhere wrong.
But I would still say that's not a very high variability. I mean, because we're doing the experiment in a very ad hoc manner, we ideally should say, put your hand in this particular angle at this particular light intensity. We have not said anything. So people have done it randomly here. So unless you're getting a difference of 20, 30 between two observations, and more or less it's fine. Okay, let's discuss this.
So what sort of signal do you see?
Okay, in the meantime, we can go with the second question.
So I have two questions.
Yeah,
One is how is the frame rate
very good question. Yeah.
helps? Does it help or does it not help? So
Yeah.
like current smartphones have the option to capture in slow mo, right? So you can have like 120 or 240 frames per second videos. Does it help?
Right, I'll come to that. So let's discuss that. We have done some coding. Let's do some little bit of theory, maybe little bit. It's not boring, it's interesting. So I wrote these numbers for a reason here. The normal heart heartbeat that we have is 30 to 150 is very high anyway, right? Unless you are running from here to your hostel, it still won't touch probably 150. But yes, it's possible. It could touch. Um, the highest heartbeat I think that you can theoretically have is 200 minus your age, right? So that's usually taken as a, that's some mathematics behind it. Why is it? That's the highest heartbeat. You can even cross it, but that's not the question here. So so we have assumed 30 to 150. It could be as low as 30. 30 is also very out of range. So usually when you are sleeping, it is about 50, it could go to 50, which means you're very healthy. If you're sleeping and it is still around 60, 70, uh, that's not very good, right? And during where you're sitting, it should be around 72 to 80, which is fine. Mine is 93 because doing effort, standing, and I hope it's normal. Okay, so from this number, so so that gives us a ballpark figure where the number should be, right? We know some that comes from domain knowledge. Someone who knows about heartbeat or something like that, very basic, right? From there, we have a frequency count, like what frequency should be looking at, because at the end we are using Fourier transform to look at the majority component, and from there we are reducing the heart rate. Now the question is, given that you know this is the frequency component, right? Can you answer more fundamental questions? First question is, initially, I think Ayush was asking you, all of you, about what is the frame rate. We were asking some of you, and some of you said 60, some of you said 24, 23, 30, something like that. The question is, what should be the ideal frame rate to absorb this signal? And you can expand this question: does higher frame rate help, or should it be lower? But at least you should answer the question: what should be the frame rate, right? And then one is frame rate. Second question is, we asked you, I think, to record 10-second audio. Is there any reasoning behind that? If yes, why? If no, why? And what should be the minimum duration that you should record? Right? These are some questions we have to answer theoretically, right? So we'll come to that depending on how much time we have. But even before going into that, do you have, why do you think this is important at first place? You don't place any? Yeah, that is correct. Yeah, that is correct. You need to capture it so that you capture the frequency. But what about time? Like we were saying 10 seconds. Does it matter? 30 seconds, 60, of course. You can do direct 60 seconds and directly calculate beats per minute, because in a 60-second, I can just count number of peaks and it's directly beats per minute, right? I don't have to do any back calculation. But my question is fine. We'll come to those numbers. Those are some basic signal processing calculations that you will understand that's straightforward. My more fundamental question is, why is this important? She gave one answer so that we do not waste any bits. That's correct. Any more answers? Okay. Okay. Fine. Yeah. Not a wrong answer. It's definitely a consideration. I'm looking for a more grounded, more fundamental answer. So, your hint is that where is I didn't. Can you? Yeah. Okay. Again, yeah. Not incorrect. One of the correct answer. Again, looking for a very fundamental answer. So, just a hint, just to frame that answer. Um, we already have smart devices which measure our heart rate, right? We don't actually need phones. We're doing the phones because it's kind of easy to explain the concept and do. But a more fundamental device which measures heart rate is, like, which we're wearing every day, smartwatches, right? So smartwatches. Now, can you frame the answer with respect to that? Why is the timing important? Why is determining frame rate important? We have gone from phone to smartwatches. The importance, phones are powerful. Exactly, right? The compute power that is required, because smartwatches are very tiny devices. The one factor which significantly impacts smartwatches are its battery life. If you spend too much resources or battery computing these things, you are wasting a lot of resources. So making a strategy like how long should I record to take, so that has to be optimal. How long should I record? At what speed should I record? Speed is that frame rate. Of course, smartwatches are doing it in a similar way. It's a small camera. Instead of a good high quality camera, they are using a LED, which is also kind of a camera. It is like a 1 pixel camera, right? And now these numbers suddenly matter to me. How long should I record? And at what frequency should I record, right? So something to think about.
I think that's it. So I hope it works for everyone. So we wanted to show you that these small hands-on can always be built.
So
Like your regular stuff.
if you want, if you're not bored, we can quickly go into the numbers, how we calculate those numbers. But that is on demand.
So the second question was, let's suppose I am not using flash, so I'm putting my finger on the camera. Now we know that there is some flickering in the light, in the artificial light, right? So the beats that is getting captured by the sensor of the lens, is it somehow capturing the flickering, or what if we did in the sunlight?
Right.
Does it impacting some way?
It does impact. So that's why we are doing the frequency analysis.
Right.
So the hope is that the flickering of the light and your heartbeat are in a different frequency.
Okay.
Right. So the frequency plot that Ayush was showing, we had only one peak there. In case of there is a flickering, there will be multiple peaks or at least 2 peaks. And then the question is, which peak do you choose? Now you don't know. And that's why we need a reference signal, your actual heartbeat by strapping
Right.
ideally stethoscope, right? And then we compare which peak is it to identify, like, yeah, I'm sure this is the peak, because the intensity of the peak will be different because your finger is closer to the lens.
Mhm.
So that will be a stronger signal compared to flickering, because flickering is a more of a global phenomena. It's not happening there. So
Right.
the hope is that we'll be able to see these changes in the frequency plot. And that's why we do frequency and do not rely on peak detection
Okay.
technique.
Okay.
So that is the answer. Yeah. Yeah.
Or to add on to that answer, generally what happens is that your flickering is obviously going to have a higher frequency. And the chances that it exists in the same frequency range is generally low. Because let's say flickering could happen because of electricity and such stuff. Your tube light and all those devices would flicker at a even higher rate, not at the rate of, let's say, point. So our signal is of the rate 0.5 hertz to 0.5, correct? But your electricity comes at 50 hertz. So maybe it flickers at that rate. You would have filtered it out. That's why filtering is important.
But yes, if the flickering is at same frequency and your heart rate is same frequency, it might happen. It's a problem. It's a major problem, which is kind of, it's not even considered an open research problem. It's kind of a problem. So you cannot get rid of.
Sunlight helps.
The clearer the background, the better. But not the background, the clearer the background light. That's why smartwatches have that light projecting into you.
Yeah, means in sunlight there is no flickering, right? I guess. So
That flickering, as Ayush said, it's a very different frequency.
so hence I don't think there will be an issue, because let's suppose you train a model on let's suppose in this room,
Yeah.
data captured from this room, right? Now the frequency of this light may be different. Let's suppose someone is using in some different room, but the pipeline may not fit well. There can be the different frequency. That's why I'm asking.
First answer is that the frequencies are different. And second, in sunlight, in fact, it helps to get a better quality signal because the blood vessels become more brighter.
Okay.
So that signal to noise ratio suddenly goes very high.
Okay. Okay.
That in fact becomes better and the flickering signal is
Also, I'll complement that answer. A lot of times signal processing is powerful enough to not need a model. So you would do Fourier analysis or search analysis, so you don't even need a model. So you have thrown the model out. Things just work right out of box. That's a good thing with signal processing.
yeah. Okay. How much time do we have?
I think we can close. We are done.
Okay. No one wants to know what is the sampling rate required. Like, why is this number important?
I think they're bored. They want to
Okay.
go.
Fine, won't trouble you.
Okay, guys, we see you tomorrow then.
Okay,
Huh?
Okay, we'll keep this optional.
Kal chutti hai. Okay.
Yeah,
see you
we'll
on
keep this
Sunday.
optional, no force, like it's chill. I'm just going into some basics of signal processing, how these numbers are determined. Some people want to continue, so I'll just for them
Sure.
just do it. Probably just take 10 minutes. So what I was saying is, once you know the range of numbers that you have, and you then have the frequency. Now the question I was asking is, what should be the frame rate? Now frame rate, for those who are a little confused, frame rate is how many frames you are capturing per second. This is same as another term which is used in signal processing is sampling rate. How many samples per second? Same thing. How many frames per second? How much samples per second? The question is, in signal processing, whenever you capture signals from anywhere, whether it is this one or you are capturing, this mic is capturing my audio. So I'm also speaking at something and it's a digital system, right? It's more of a electronics, but it's a digital system at the end of the day. It's not continuous. So it is a method of capturing the signal. So the basic formula is that someone said that their phone is capturing at 60 frames per 60 frames per second, right? So if it is 60 frames per second in signal processing, there is a thing called Nyquist rate. How many of you know about Nyquist rate? Yeah, you know, right? So can you say what is that? Right. Right. Yeah. Yes. So Nyquist rate. So formula says that if a frame, someone said it is 60. So if it is 60, you just divide it by 2 and you get 30, which means this is the highest frequency that you can capture. So it goes to, this is the highest component. 30 hertz you can capture. Someone's phone was saying it was just 25. So in that case, you can just measure 12.5 hertz. You cannot go beyond that, right? So now given that we know it is 2.5, so the highest frame, the minimum frame rate that we need is just 2.5 into 2, which is capturing 5 frames per second is just fine, right? So if I can capture 5 frames per second, instead of capturing 60, I can just get rid of frames and capture 5. Well, that will give me an immediate advantage because now I'm not computing a lot. Collecting 60 frames is a lot of things, lot of job to do for the processor. So you have to now just pick 5 frames and your processor load is low, your battery consumption is low. Doesn't matter in phone because phone has strong batteries, matters in smartwatches. So these are design decisions that you need to take. And these are backed by solid numbers, Nyquist rate. This is highest I was saying, right? This is the highest. What could be the lowest? So highest is linked to number of frames or number of samples per second, the frame rate, right? Divided by 2 is the highest. What's the lowest? So to determine the lowest, I'm throwing formulas here, I'm not discussing why this is the case. To determine the lowest, this is the highest that you determine. To determine the lowest, so suppose you are all capturing 10, right? 10 seconds. So it is 1 by 10 seconds. It is the reciprocal of the time duration. 1 by 2. So 1 by 10 is 0.1. So the lowest frequency that it can capture is 0.1 hertz, which is fine in our case, right? In fact, we can make this lower. So 0.5 cross 2 is 1. So theoretically, capturing 1 second signal is enough. Theoretically. Practically, capturing one signal doesn't make a lot of sense. So probably capture 2-3 seconds, right? But that is enough to give you a heart rate signal. So again, not important in smart phone, important in smart watches, because you need to determine to consume lesser and lesser battery. Okay. I have just thrown some formulas. Nike state is known. Why it is like that, why it is like this, that's a different story. So in very basic, you have a signal like this, say, this is a signal. So can someone look at this and tell me, suppose this is 1 second, this point is 1 second, right? What's the frequency of this signal? 1, right? 1 hertz, because there's 1 cycle in 1 second. This is 1 cycle in 1 second. Nike state, this is again not advanced, actually very basic. Nike state basically tells me, so this is a continuous signal. I'm speaking, this is continuous. There is no digital between this and this, right? If I'm continuously speaking, so signal is something like this, which is going on. But the digital process inside this is not capturing continue. It cannot. It's a digital signal. So the Nike rate says at what rate should a minimum pick the signal? So digital, you know, right? It takes digital points. So to reconstruct this signal digitally, if I have to reconstruct this, how many minimum points do I need to capture? Just to break it down further, this is continuous signal I'm speaking. This is continuous. I cannot record everything because it's costly. Processor wise, battery wise, power wise, I cannot do that. The question is, how many minimum should I pick up so that I can reconstruct this signal? Yeah, you can quantize at levels. That's true. You can do this quantization. But question is, what is the minimum lines that I can draw so that I can reconstruct this signal? And that is Nike's rate, right? Because, well, we do not have lot of time, and I'm always excited about such. I'm doing it. Minimum, you just need to capture 2, 1 here, 1 here, 1 here, 1 here. And you hope that your signal that you're constructing is like this. The problem, it could be like this. It could be like this only. I don't know. So that's what Nike's rate is, the minimum, right? It's not enough. So when we are saying that with 60 frames per second, you are capturing 30 hertz, theoretically, yes, but practically not practical, because capturing 30 hertz, better to have more signal. Just like this one. Here, this is 1 hertz. So I need 1 cross 2, so 2 points, right? So just some basic idea how this concepts are. I'm not teaching you this whole, this is like a 1 class lecture to explain this. I'm just telling you there are methods to determine these numbers rather than doing everything through machine learning, right? There is mathematics into it, and it takes time to sink in. And this is actually very basic signal processing concept, but it takes time to understand what's going. So the whole point is there are methods to these numbers. And why this is important? Because we want to consume lesser and lesser processor and battery. And then we determine this number and then we do the calculation. The innovation is not on extracting the signal and showing it, that everybody can do. Can you find bounds on these numbers and tell that, okay, you know what? I need to just capture 3 seconds. So someone can write a research paper and say, you know what? I don't need 10 seconds. I just need 2 seconds of your video and I can get that, determine your heart rate. Tomorrow, a friend will say, you know what? Not 2. I can now do it in 0.5 seconds, right? That's what research people do, right? And in industry will make the watch. They will take this knowledge and make it. So just to give you a flavor of it, if you want to talk about it, I'm here. We can discuss further. If and only if you're interested, no pressure. You are now free from my side. Thanks.